We're on to question 10.2. Let's have a look. A 4-digit code is required to open a combination lock. The code must be even numbered and may not contain digits 0 or 1. Digits may not be repeated. It then goes on to ask us how many possible 4-digit combinations are there to open the lock. So what I'm going to do is let's first get to understand the question. So it starts off where it says we got a 4-digit code. 1, 2, 3, 4. The next thing it says it must be even numbered. So how do you make any number even? You end off with even numbers, 2, 4, 6, or 8. Then it says we may not use digits 0 or 1. So in other words, we got 2, 3, 4, 5, 6, 7, 8, 9, and 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, and 9. So those are the possible numbers which are available for each slot or each digit of the code. Now let's have a look on the left hand side. How many possible 4-digit combinations are there? So let's have a look. 1, 2, 3, 4. So if I had to look at the problem, I would start with the last digit. Why? Because we know it can be 2, 4, 6, or 8. So one of those digits can fit in there. Therefore, this can be 4 digits. Let's say, for example, 2 is used in the last column. That means 2 cannot be used in the first column, which means then there's 1, 2, 3, 4, 5, 6, 7 digits available for the first column. If we used, say, for example, 3 in the first column, it means we can't use 2 and we can't use 3 in the second column. Why? Because it says digits may not be repeated, which means then we got 1, 2, 3, 4, 5, 6 numbers available. And so we could go on and we could say the same for the third column. In other words, to find out how many combinations there are, in the first one will be 7, second one will be 6 numbers, third one will be 5 numbers, fourth one will be 4 numbers. That means that there are 840 different combinations available to us. Question 10.2.2. Calculate the probability that you will open the lock at the first attempt if it is given that the code is greater than 5,000 and the third digit is 2. So let's quickly work this out. Let's quickly understand the question. Let's see 1, 2, 3, 4, 5. This is 5,000, but the number is greater than 5,000. So in other words, the very first one or combination we can use is 5001. Then let's build on what we know. 1, 2, 3, 4. We know these are numbers 2, 4, 6, and 8. And before I write all the number possible permeables available, let's just have a look there. It says the third digit is a 2. So this one is a 2. It's a given. Remember, we are not allowed to repeat digits, therefore we cannot have a 2 over there. Now, let's jump to the first column. It says in the question that the code must be greater than 5,000. So as you can see over there, the first number is 5, then there'll be 6, 7, 8, 9. So the numbers that are available for the first column are 5, 6, 7, 8, and 9. Then for the second column, which numbers are available? Well, actually, all the numbers except numbers 0, 1, and 2, because 2 is dedicated to the third column. So we got 3, 4, 5, 6, 7, 8, and 9. The next way I would approach this is by taking each column and making it a sequence. So if we take this column, it means I'm going to end with a 4. So the only number that can go in the last column is one number. It's 4. Let's multiply that. The only number that can go into the third column is 2. So there's only one number available. Then let's jump to the first column. Therefore, we can use 1, 2, 3, 4, 5 different numbers. We can use 5 different numbers there. So let's say we use the number 5. That means in the second column, we can't use the number 5 again. That means we've got 1, 2, 3, 4, 5, 6 numbers available. But we've used the number 4 already. Therefore, number 4 is also out. Therefore, we got 1, 2, 3, 4, 5 numbers. So the possible combinations for a code ending with a 4 is 5 times 5 times 1 times 1. And then we can do it again for the 6. In the last column, we're going to use the number 6. There's only one number available there. Third column, there's only number 2 available over there. We jump to the first column, but now we've used the number 6. So we can't use it again. So how many numbers are available to us now? Well, it's 1, 2, 3, 4. We have 4 numbers available to us. So let's say once again we use the number 5. So number 5 is not available, but number 6 is not available. So how many numbers are available to us now? 1, 2, 3, 4, 5. There's 5 numbers available. So the possible combinations for a number ending in a 6 is 4 times 5 times 1 times 1. And so we can do it with the last one as well. How many numbers are available in the last slot? Only number 8. We can use number 8 here. How many numbers are available in slot 3? Only 1, number 2. Let's jump to the first column. In the first column, we now have number 8 taken. So we can't use that. So how many numbers are available? 1, 2, 3, 4. So there's 4 numbers. And let's say, for example, we use the number 9. Therefore, the number 9 number is not available. Number 8 is also not available to us because we use it in the last column. So now we've got 1, 2, 3, 4, 5 numbers. So having said all of that, I'm going to write on top here. We have 5 times 5 times 1 times 1 plus 4 times 5 times 1 times 1 plus 4 times 5 times 1 times 1. Those are the possible combinations. So let's quickly punch it into our calculator. If you add all of that up, you'll get 65. But that's not where the question ends, because the question wants to know what is the probability that you'll open the lock at the first attempt. So in question 10.2.1, we know that there were 840 possible permutations. So now what we have to do is the probability would equal 65 over 840. And if you punch that into your calculator, you'll get an answer of 0.08. Thank you for watching the video. If you have any questions, please drop your question in the questions below. We'll read and respond as soon as possible. If you need more help with math, please click the link below. That goes to my channel and go view what we have available there.